Recording in progress.
Okay. Hello, my name is Edgari. I'm a computer science student in Business International. I have been given the privilege to act as the main presenter from my group on this conference. Without further ado, our research paper title is Comparing Deep Learning-Based Architecture for Logo Recognition. It was authored by our team, which consists of me, Edgari, Gardyan, Bentley, our lecturer, Miss Nurul, and Sir Ardimas. We're all from Computer Science Department, Faculty of Computing and Media, Bina Nusantara University. So for the introduction, actually logo recognition is one of the most important tasks in machine learning, despite being a subset of object recognition problems. Logo recognition has a wide range application like intelligence traffic control, copyright infringement, and brand recognition in marketing social media. Imagine that an artificial intelligence can surf around the internet into finding if there was any copyright infringement found using the logo. Basically, in this 21st century, everything is like a digital book. By using logo recognition, we also can find how to judge whether our brand is recognized by social media, by the market in social media or internet. I think this is a key feature that businessmen found it interesting why logo recognition can solve a couple of problems in business section. They can know whether their brand are successfully marketed or not, and then they can plan further for what to do with the next marketing plan. For the next slide, for the related work, actually our works were motivated by from the Bianco paper, from this paper, Deep Learning for Logo Recognition by Simon Bianco, Marco David, and Raimundo. In the end of the Bianco paper, we mentioned at Bianco paper, they compare their model with others without conducting the same pre-processing pipeline. Basically, their logo recognition without the same pre-processing pipeline. The result is that their model outperformed others. It is not clear whether the gain comes from the new architecture or the added pre-processing pipelines. Basically, that's the main idea why we divulge into this paper. Therefore, in this paper, we focus on investigating the architecture without a logo region proposal. We use a new architecture and pre-training compared to the paper. We also use new pre-processing method. For the architecture itself, we choose three. So the first one is actually the Bianco's model, actually the models from the paper. We named it, referred it as Bianco model to prove whether the result is actually from the architecture or the pre-processing method. The second one is the AlexNet. We choose it because it's considerably very lightweight. And the last one is the exception. Exception just because it's of the complexity of the architecture. Actually, in this picture, we only have 30, but actually from the paper itself that we write, we have first 52 because it's not fit in the presentation. I just want to explain that we use exception because it's complexity for that. So for the next slide. Okay, so this is actually the data set. This is what we kind of proud for because for the purpose of this research, we use the electronic logo dataset. We try to find electronic logo dataset, but sadly there are no readily available datasets of this area. So we have to take the images from generalized datasets and recompile it as one new datasets. So this is where we recompile all our datasets. So the first one is from the Flickr logo 27. 32 plus Selenium WebDriver brand logo and etc. So for further explanation, the Flickr logo 27 consists of 27 brand or company logo downloaded from Flickr. The logo 32 plus, the Flickr logo 32 plus is an extension of the Flickr logo 32 datasets. For this data cleaning was required as some images contains multiple logo of the same brand. Actually, this task was done manually because there's a multiple logo design brand. We need to actually manually to clean the data. So for the next one is the Selenium WebDriver. Actually, Selenium is an automated web application testing. So one of its feature key feature is taking screenshot of user inputs and of the application output. So basically, we write a Python script to perform web scraping for the image of the logos needed with this technology. So yeah, we use web scraping using Selenium. The next one is the brand logo. This one compiled by Nupur Pahuja, consists of various tech companies logo. Cleaning was needed because the dataset consists of older version or multiple instances of the same logo in one image. The next one is the logo.30k datasets. Large scale image dataset consists of 150,000 logo. This one we don't need to clean it. And there's a dataset brand of company compiled by Lurtupun Power and scrapped from Logodix. Additional cleaning was needed because there was a duplicate image and etc. etc. And the last one is our own dataset. Actually, we tried to gather a couple of datasets for for our experiment. It's only a few. So this is the diagram of our datasets. Basically, we only have the three classification: Apple, HP, and ROG. Yeah, this is the diagram. For the next one, so the datasets, this is the description. All of the scraping that we done in the internet and collecting from the internet resulted in our dataset distribution with 1,636 training plus validation image, and we have 461 test images. So the methodology is like this. This is how we want to compare the tree architecture itself. So three of them use the same methodology. At first, this is the proposed classification pipeline. The first step is we load the dataset with TensorFlow. We use TensorFlow for this experiment. We load with the validation split of 0.2. This gave us approximately 1,309 training images and 327 image for validation. The next step is we're converting image into 3-color channel grayscale. Since the architecture accepts 3 channel inputs, we need to duplicate the grayscale data to other additional channels. So the next step is the normalized datasets. There are 255 possible colors in one channel. We proceed to normalize it into the range between 0 to 1. The next one is the data augmentation. With the image itself, approximately almost 2,000, we find it still small. Small dataset, so we perform a simple data augmentation to increase the size of our datasets. Basically, we shuffle the images, we perform random flips, and implemented random rotation. And the last one is data labeling. We use the method of one hot encoding. In this method, each category value is converted into a new column and assigned into the value of 0 or 1, which 1 or 0, which indicates 1 is for true, 0 is for false. Okay, so the next step is this is the training framework. So basically, that classification pipeline is the first step before we train our CNN. So to actually make the comparison in a fair environment, we use the same optimizer, which is Adam, and categorical cross entropy loss function. This is the loss function. This is the optimizer. So the framework is that we go through the pipeline and then CNN training with the optimizer and loss function, and then we have the train CNN. Okay, so this is actually the result that we have. This is for first Bianco model, a second AlexNet, and third exception. So for the accuracy, actually, exception no doubt give the higher result because of the complexity of the architecture. But for the Bianco model, actually, it is quite low, 66%, and the AlexNet is like 61%. I think that's the key highlight for this result. Yeah. For the next is the time. The time floating point operation per second in giga and execution time in milliseconds result. So basically, we want to check which one is the fastest, the most lightweight, and etc. All of the training are using this specification computer, same specification hardware, the Intel i7, RAM 32 gigs, and RTX 2070, 8 gigabyte. So for the time, this is the time for the training time to complete architecture training. As expected, Bianco models already mentioned that their architecture has the lightweight training time. It's like we finish it at 4 hours, at 5 hours, and exception, because it's quite powerful and quite complex, the architecture itself takes almost 7 hours. For the flops, we actually measure it using the flops to check whether the computational cost. It's more higher. It's like as expected, exception score higher too. And for the execution time, it's actually the time we need to actually identify the logo using the architecture itself. And exception also give the highest execution time. For the key thing is we want to compare actually the beyond cost model from our experiment and the model from there. So as you can see, the accuracy itself is need to be highlighted that it differs so much. It's almost 30%, and we only got 66%. So what we can find out is that their approach using the logo region proposal or the complex image pre-processing method is actually increase their lightweight architecture to become more efficient, become more powerful. So their approach use a complex pre-processing method. They use ground truth and object proposal, logo annotation, more complex data augmentation, class balancing in its epoch, and contrast normalization on pre-processing. Basically, the pre-processing method is more powerful because unlike we only put the image directly to the architecture. And also, I think another contributing factor would be the different quantity of datasets. Actually, they use Flickr 32 and L32 plus dataset with total image of 8,000 and 7,000 respectively. It's like 15,000 of images, where we only have 2,000 images, and we scrap it and manually clear the dataset itself. So for the conclusion, for now, as we compare the three of the architecture, accession offer the best accuracy, but although it's offer the best accuracy, but it's also the most powerful, and so therefore the computational cost is more higher. But actually, the model from the paper, the Bianco models, is actually give a decent, we can say decent, because it gives 66% accuracy, but it's quite lightweight. So depends on the scenario. You can choose whether you want to choose the more powerful but more computational cost, or for the more which one is more lightweight. The next conclusion that we found is that pre-processing method proven to increase model results. It's proven by comparing our model, which we train ourselves with the model from the paper, from the Bianco paper. For the future work, actually, we want to test complex image processing method combined with powerful architecture such as exception. The idea is that they already tried combining a lightweight architecture with a powerful, with a complex preprocessing method. We wonder what would happen if we combine it with exception architecture, which one of right now is quite the one of the most powerful architecture itself in this category, in this object detection. And the second one, we want to investigate whether every architecture has an increased performance given the same preprocessing method. How much? So basically, we want to check if we use the same preprocessing method, does it always increase the accuracy? And we wonder how much it can increase the accuracy, and so forth. So that's our future work. So I think that's all for the presentation. I want to thank for my teammates and author and the reference and the paper. So I think I'm done. Thank you.
Okay, thank you for Mr. Edgari for the presentation. Now, if anyone has any question, please put your question in the chat or raise your hand. Any question? Thank you for your presentation, Mr. Edgari. Please allow me to ask, can you share with us about the future chance and challenge of your research? Thank you.
Yes, for the future challenge, actually, I think we think that we need to find the actual pre-processing method that can increase. Obviously, we can choose the one from the paper, but we also want to diverge it. We also want to find out which one is better and actually find the more I guess more uniform method that can be used to all architecture itself. Yeah. And then I think we want to increase our dataset itself again. It's still only 2,000 images. We specifically focus on electronic logo. We also want to contribute to the community so that we can gather more electronic logo to the community. So, but finding the logo itself is quite challenging and itself. So, I think that's the key point for the challenge that we going to face in the future.
I think the Q&A time is over and we should go to the next presentation. Then, to save the time, next please welcome our next presenter, Mrs. Hanifah